In this video, we'll look at how you can use a graph and a graphing calculator to solve a rational inequality. We want to use the graph of f of x equals x plus 3 divided by x minus 4 to solve the inequality f of x is less than 0. So the first thing we want to do is input our function into the equation editor on the calculator by pressing the y equals key. And then we're going to input the numerator and denominator of this function in parentheses. So we'll have parentheses x plus 3, close parentheses, divided by parentheses x minus 4, close parentheses. And then we can graph in the standard viewing window. Now when we graph, recall that there are properties of rational functions. That is, we know they have vertical and horizontal asymptotes. The vertical asymptote occurs where the function is undefined, which is at 4. So at 4, there is an imaginary vertical line going down this graph. And we know that the function will never cross that particular vertical line. There's also a horizontal asymptote that comes from the relationship between the numerator and denominator and the degrees, because the numerator and denominator have the same degree. The horizontal asymptote is the ratio of those leading coefficients, so in this case would be y equals 1. So there's also a horizontal asymptote at y equals 1. Now we need to figure out the part of the graph that is below the x-axis. We want to solve where f of x is less than 0, that is where y is less than 0, and that corresponds to points that are below the x-axis. If you recall from the previous video, we had to find the zeros of this function, that is, where does a function equal 0, and that was at -3. And so I'm going to use another color to draw kind of the regions that come from the zeros and where it's undefined, that is the boundary number. So at -3, the graph crosses the x-axis. And then at 4, we've already got a vertical asymptote drawn there, but the function is undefined there. So those two vertical lines divide the graph into 3 regions. We can call those A, B, and C, where the region will either be below or above the axis. And the only region where the graph is below the x-axis is in region B. So my solution set would be then from -3 to 4. I have to exclude the 4 because it's a vertical asymptote, the function is undefined there. And then the -3 has a parentheses because I'm not permitted to equal 0, just be strictly less than. I can also take that one step further and look at the table. And in the table, I can see that -3 has a y value of 0. That was my boundary number. 4 is where the function is undefined. That's where I get that error message. So again, from this table, I really have kind of those test points, right? To the left of -3, the y values are positive, which are not less than 0. Between -3 and 4, all of the y values are negative, so that's the region that satisfies that inequality. And then to the right of 4, my y values are positive, which again does not satisfy the inequality. The other thing that we can do in the graphing calculator is actually to input the entire inequality in the equation editor. So I could input the expression x plus 3, that is in parentheses, divided by, in parentheses, x minus 4 is less than 0. Recall, to get the less than symbol, I have to use the test menu, which is second math. And then I'll see a list of the inequality symbols, and I want to choose a less than. And then if I graph that in the standard viewing window, remember that this is using Boolean algebra. It assigns 0 to an x value that makes it false. It assigns 1 to an x value that makes it true. And so everywhere we see a graph of 1, that is where y is equal to 1, we know the solutions lie there. And so the only region that contains solutions are between the -3 and the 4, which confirms what we just saw with the graph of the function. So again, my solution is from -3 to 4 in interval notation. On the number line, I would have to shade the region between -3 and 4 with the parentheses on each of those numbers.